Hello everyone, welcome to the lecture 5 of the course Diffusion in Solids. So this is what is the tutorial lecture. Basically every week's content we will have some problems to practice, which will also help you to solve the assignment, as well as it will also help you to revise the concepts that we covered in this week. So my strong suggestion to you is that when you are solving or reviewing this lecture, once you have seen the problem, pause the video, try to solve it yourself first, and see then whether your answer matches with the solutions provided. And if you think of any alternative ways of solving the problem, you are also welcome to share that on the forum. Okay, so basically in this week we talked a little bit about the introduction to diffusion, some historical developments that have happened in the field of diffusion. Then we also revised some of the mathematical concepts that will be useful in solving the diffusion equations and moving ahead. Then we also talked about the Fick's laws of diffusion, the first law, the equation of continuity, and the second law. And we also talked about the Laplace transform, which the application of it we will see in the next week. So let us start and try to solve some problems today. So the question number 1 is an objective type question. Which of the following is a diffusion controlled phenomena? Just remember that your assignment as well as later your exam papers may contain objective questions where there may be multiple correct answers. Okay, and wherever there are multiple correct answers, we need to identify all of them correctly. There is no partial markings that are there. Okay, so which of the following is a diffusion controlled phenomena? The options are solidification of metals, grain boundary migration, the nucleation of a new phase, and the precipitate growth. And actually, if you see, in each of these processes, diffusion of atoms is involved. During the solidification, when you formed a nucleus, there similarly nucleation of a new phase, if it is a solid state transformation, then also you require the diffusion of atoms. The atoms have to come together to form a new phase. Similarly, migration of grain boundary requires the transport across the boundaries, and the growth of the precipitate also. If you have some exposure to physical metallurgy, you would or phase transformations, you will know that the growth of the precipitate, the kinetics is covered, involved, diffusion is involved in that. So basically for this question, all the answers are correct. So all of them are diffusion controlled phenomena. Moving ahead to our second question, which is pretty straightforward. According to the Fick's first law of diffusion, the diffusion flux is linearly proportional to. And if you remember, J is equal to minus d times dou c by dou x, that is in the simplest one-dimensional form, in the Cartesian form. So there you see that that was the original intuition of Fick's, with which he proposed that law, that the flux is proportional to the driving force, which is the concentration gradient most of the times. So although remember that the flux is also dependent on temperature, because the d is dependent on temperature, the diffusion coefficient is dependent upon temperature, but the proportionality is not linear. Same thing with the diffusion distance also. It comes into picture, but it is then not linear, and same with time. So in the case of non-steady state diffusion, the flux may change with time, but it is not a linear dependence. So the correct answer is B. Now let us move to the third question. Which of the following are the characteristics of a non-steady state diffusion? So non-steady state diffusion, where dou c by dou t is not equal to 0. So the first option, concentration at a given point changes with time. This is correct because as I just said that dou C by dou T is not equal to 0. So, the concentration at any point changes with time. The diffusion flux is constant. This is not correct. Flux is constant when the steady state is achieved. So, the diffusion flux is variable. So, this is not a correct statement. It applies to processes such as absorption of gas. Yes, the gas absorption, once the gas is absorbed on the surface, this we will also see in the next week's lecture when we take the example of degassing and so on, that the gas absorption is actually a non-steady state diffusion. And the concentration profile is linear with respect to the penetration depth. This is not usually observed. You will see next week when we derive also that it is not necessarily linear. It is has a more exponential or a more complex variation with respect to the penetration depth. So, the correct answers are A and C. Now, a few problems related to some of the mathematical concepts that we saw in this week. So, the first is find the derivative of this function, which is x sin x into 3x square minus 9. So, remember that this is a product of now 3 different functions. So, to simplify, what we do is, let us take u is equal to x sin x here, and v is equal to 3x square minus 9. So, your z is now u into v. So, the dz by dx can be written as, remember u and v both are function of x. So, now you can apply the product rule and you can write u times dv by dx plus v times du by dx. And now your u is x sin x. So, the du by dx, again a product rule has to be applied. So, x first, differential of sine is cos, plus sin x, differential of x is 1, we know that. And then you have v is equal to 3x square minus 9. So, here dv by dx becomes 6x. So, if you combine 1, 2 and 3, what you have is dz by dx into x sin x into 6x plus 3x square minus 9 into x cos x plus sin x. And if you rearrange a little bit, you open the bracket terms. So, you get these terms 6x square sin x plus 3x square sin x becomes 9x square sin x here. And if I just rearrange it a little bit more, taking x cos x 3x cos x common, I get x square minus 3 plus 9x into 9 sin x outside, x square minus 1. So, this is the solution. If you have not, even if you do not simplify it till here, but you get the correct terms, it is okay, but it just looks a little better when you have simplified it. Now, we talked in detail about the Laplace transform. So, here is a function where you have to find the inverse Laplace transform of the function that is given. So, you are given already the Laplace transform, you have to find the original function. So, now let us say that this particular function f of s is equal to 8s square minus 4s plus 12 divided by s into s square plus 4. Now, when we want to find inverse, we usually, for this kind of an expression, since there are factors here, we use the method of partial fractions. So, how do you use partial fractions is here it is because it is still s. So, you simply write a by s plus whenever there is a quadratic expression here, you write bs plus c by s square plus 4. Suppose if there were two quadratic expression, this also would be a something like as plus d or something like that. So, this is equal to 8s square minus 4s plus 12 divided by s into s square plus 4. And now, if you cross multiply, the denominators here will cancel, and what you get is a into s square plus 4 plus bs plus c into s is equal to 8s square minus 4s plus 12. Then if you just open the brackets and collect the terms of s square, you have a plus b plus cs plus 4 times a. Then that is equal to 8s square minus 4s plus 12. Now, if we compare the like powers of a, it is very straightforward that c is equal to minus 4 and 4a is equal to 12, so a is equal to 3, and a plus b is equal to 8 here, so therefore b is equal to 5. So now what you get is f of s, if you put the value here, 3 by s plus 5s minus 3 by s square plus 4. Now, from the table provided in lecture 4, that is the previous lecture, we know that the Laplace transform of 1 by s is a constant 1, and whereas the Laplace transform of s by s square plus a square is cos a t, and Laplace transform of a by s square plus a square is sin a t. So now if you want to apply this here, we just rearrange them a little bit. So we write as 3 into 1 by s plus 5 into s square plus 4 minus, I multiply 2 here and divide 2 here, because you see here this is s square plus a square and I should have a here as well. So I just multiply it by 2 and divide it by 2. So I write minus 3 by 2, 2 by s square plus 4. So now it comes in this format, a by s square plus a square. So the inverse of this is 3. Here the inverse of 1 by s is a constant, so it is 1. So it is only 3 plus 5 multiplied by the inverse of this is cos a t, where a is 2 here. So you have cos 2t minus 3 by 2 sin 2t. Okay. So here you see that we are invariably using the property of the linear operation of the Laplace transform. So this is the solution. Now the next question is basically just for your understanding of continuous, piecewise continuous or neither on this interval 0 to 3. There is a function given. So you see that this function has different expressions. In 0 to 1, it is t square. It is 1 in between 1 to 2, it is 1 by t minus 1, and in between 2 to 3, it is equal to 1. So let us, if you try to sketch this function, so you see here that in the interval 0 to 1, it is t square. So this is how the graph would be. This horizontal line corresponds to the value of 1. Then in the next interval 1 to 2, it is 1 by t minus 1. So that means when I put just a small number 1 plus delta, or if I put 1 in this function, it goes to infinity. So there is a jump here. So you see that there is a jump here. So at values slightly greater than 1, it goes to infinity. Then when t is equal to 2, then it again is equal to 1. So there is a decrease in this function, and then between 2 to 3, it is a constant 1. So it is very clear that this function is not continuous, because you can clearly see a jump for any values less than or equal to 1, it is t square, so that gives the value 1. Whereas anything greater, marginally greater than 1 plus delta, let's say, it will go to infinity. So now let us solve one more problem where now we use the Laplace transform to find the solution for the following differential equation. So you see here that dou square y by dou t square minus 3 dou y by dou t plus 4 yt is equal to 0. And the initial conditions are given as y equal to y0 is equal to 1 and y dash 0 is equal to 5. Now, how do we go about it? We have seen one example in the lecture itself. So basically, I am writing dou square y by dou t square as y double prime minus y dash plus 4y is equal to 0. Now, because we are given already these conditions, so now let me take the Laplace transform of the both sides. So it becomes Laplace y double prime minus 3 times Laplace of y prime plus 4 L y is equal to 0. Now, according to the theorem that we saw in the last lecture, you can write L y double dash is equal to s square L in L of y minus s into y of 0 minus y dash of 0. So this is the theorem that we saw in the previous lecture. So s square L of y minus s into y of 0 minus y dash of 0 minus 3 times. So this also can be split as s into L of y minus y 0 plus 4 times L of y. Now, let me just call L of y as f of s for now, and therefore, if I write these values, I put y 0 is equal to 1 and y dash 0 is equal to 5 here. So you will see. So you see that I have put already here, but I would strongly advise that first you try to solve it yourself without seeing the solution, so that you get more confidence here. So then it is minus s minus 5 minus 3 times. Here also we put the value all together, and then we separate or we collect the term which contains fs. So you have fs in bracket s square minus 3s plus 4 minus s minus 5 plus 3. So what you get is f of s is equal to s plus 2 divided by s square minus 3s plus 4. Now, on the first look of it, you may feel that it can be now, because now we have to find the inverse of the this function. So usually we use partial fractions when we see these kind of denominators, but if you will try, you will understand that this cannot be factorized in simple brackets. So there is a separate technique that we need to use. Let's see how do we solve it. So what we need to do is, here you see that s square minus 3s. So basically this divided by 2 and the whole square of this. So 3 by 2, the whole square of 3 by 2 is 9 by 4. So I add 9 by 4 and subtract 9 by 4 from the denominator. Why we do it, it will be clear in the next step. So you see that this was 3 here, the coefficient of s, and the half of it is 3 by 2 and the square of it is 9 by 4. So I added 9 by 4 here, subtracted 9 by 4 here. What it does is that now it becomes s plus 2 divided by this whole term is like a minus b whole square. So it becomes s minus 3 by 2 whole square plus 7 by 4. Now, this can be written as s plus 2 divided by s minus 3 by 2 whole square plus root 7 by 2 whole square. Now, usually if you remember the Laplace transform table, what you have on the top here, if you have on the top s minus a, usually in the here also you tend to get s minus a whole square. So to make that similar, I do s minus 3 by 2 plus s plus 3 by 2 also here plus 2. So what this arrangement gives me is fs something like this: s minus 3 by 2 plus 7 by 2 divided by s minus 3 by 2 whole square plus root 7 by 2 whole square. So you will see that this will be very useful now when we take the inverse. So what I can do is, now I can separate these two fractions, and I can write the first term as s minus 3 by 2 divided by s minus 3 by 2 whole square plus root 7 by 2 whole square, plus here it is root 7 by 2, whereas here it is 7 by 2. So I write it as root 7 multiplied by root 7 by 2 divided by this denominator. So again, from the table you can see that if you have the Laplace, if you have the function as e power at into sin bt, the Laplace transform of it is b by s minus a square plus b square, whereas if you have it as e power at cos bt, then you have s minus a by s minus a whole square plus b square. So now it should be very clear for you that if you apply this here, then the Laplace transform of the inverse of this should be e power at. Here in this case, or in the case of cos, you have s minus a, so you have a as equal to basically 3 by 2. So therefore you have e power 3 by 2 here, multiplied by cos root 7 t by 2, which is the value of b, plus root 7 times here e power 3 t by 2 into sine root 7 t by 2. If you take e power 3 t by 2 common, then you can write cos root 7 t by 2 plus root 7 times sine root 7 t by 2. So you see here, this is the way to find solve the differential equation, and here this was the additional trick that we used, because we could not convert the fraction as it is into a factors where partial fractions can be used. So we used a different trick here. Now moving ahead with the next question, which is basically to evaluate this integral, which is t power 7 into sine 2t power 4. Now at first you will see that this appears like, okay, there is two functions, so I should do an integral by parts. But before we do integral by parts, it would be easier to solve if we can make a substitution. So what we do is we call I is equal to t power 7 into sine 2t power 4 dt, and now t power 7 can be written as t power 4 into sine 2t power 4 into t cube. So t cube and t4 multiplied is t power 7 into dt. So now it should be clear to you that we substitute t power 4 is equal to u, so that 4t cube dt becomes du. So here t cube dt we can replace by du by 4, and you have integral u into sine 2u. And now it is much easier to apply the by parts. So you take 1 by 4, and here you have u multiplied by integral of sine 2u is cos 2u by 2 minus cos 2u by 2 minus integral of minus cos 2u by 2 into du, and the differential of u is 1. So there is 1 here, and plus the integration constant we add, and therefore now you have 1 by 4 times minus u cos tu by 2u by 2 plus integral of cos is sine, this minus and this minus become plus. So you have sine 2u by 4 total, and if you take 1 by 2 out, you get 1 by 8 sine tu by 2 minus u cos tu plus c here, and finally we substitute back u is equal to 2t to the power 4, and therefore you get 1 by 8 sine 2t power 4 by 2 minus t power 4 into cos 2t power 4 plus c. So this is the solution for your integral. Now one more problem here. The flux of a diffusing species in 3 dimensions is represented as j is equal to 3x square I cap plus 2my j cap plus z square k cap. So here this bold letters indicate the vectors. So this I, j and k are the unit vectors along your x, y and z direction. The question says that if the steady state is reached, what will be the value of m at x, y, z, where x, y, z have the value 1, 1, 1. So to solve this, we know that j is equal to given as 3x square I cap. I have written it here as I cap and vector. So plus 2my j cap plus z square k. And now because at the steady state we know that dou c by dou t is equal to 0, and this dou c by dou t is equal to minus del dot j by the equation of continuity. So you have del dot j is equal to 0, which means that dou j by dou x plus dou j by dou y plus dou j by dou z is equal to 0. And the differential of this, therefore each of this term with respect to x, y and z, so this becomes 6x, this becomes 2m, and this becomes 2z is equal to 0. Now, since we have to find a value when x, y, z is 1, 1, 1, we put this value, and what we get is 6 plus 2m plus 2 is equal to 0, which will yield m is equal to minus 4. So, now I think the last problem of this tutorial is where you need to find the Laplace transform of t to the power n, and here let us see how do we go about it. So, the solution to this equation or to this is as follows. So, you see that f of t is equal to, let us say, t to the power n. So, the Laplace of this is equal to what we write as capital F of s is equal to 0 to infinity t power n e power minus st dt. This is nothing but the definition itself of the Laplace transform. Now, here to solve this integral, let us use the integration by parts. So, t power n is our first function multiplied by the integral here of e power minus st, which is e power minus st by minus s, and the limit will be 0 to infinity, minus integration of 0 to infinity n t to the power n minus 1. This is the differential of t power n. So, n into t power n minus 1. Remember the differentiation formula. So, t power n differentiation is n into t power n minus 1 multiplied by integration of this, which is e power minus st by minus s. Now, if you look at this first term here, if I put infinity, then this particular term e power minus infinity makes it 0. If I put 0 here, then here also becomes 0. So, this overall term becomes 0 here, plus, because here there is a minus, minus minus becomes plus, and n by s can come out of the integral, and you have 0 to infinity t power n minus 1 into e power minus st dt by s. Now, how do we go about it? So, again use the integration by parts, and what you will have is 0 plus n by s, which is this, and again if we apply integration by parts, I have t into n power n minus 1 multiplied by e power minus st by minus s, 0 to infinity, minus integral 0 to infinity here, and this again now because it is t power n minus 1, the differential of this will be n minus 1 into t power n minus 2 multiplied by e power minus st by minus s. So, again by the logic that I told you before, or when you put the values here, this first term goes to 0. So, you have 0 plus n by s common, again this term becomes 0, and you have n minus 1 by s coming out here, and you have 0 to infinity t power n minus 2 e power minus st dt. And therefore, the f of s now becomes n into n minus 1 divided by s square, 0 to infinity n t n minus 2 e power minus st dt. So, you see here the similarity between this and this here. So, here after the first step, we have come to n by s this integral. After the second step, now we have come to n into n minus 1 by s square up to here, and then after you do it n times, what you will see is that you get such products here, and here also you keep on adding to the powers of s until when you have the n minus n, which is 0, then finally you will have only 1 by s coming out. So, therefore, the solution of this is represented like this, n into n minus 1 into n minus 2 and so on until it goes to 1 divided by s into s to the power n plus 1, and the above quantity is nothing but n factorial divided by s power n plus 1. So, I hope you have tried this problem yourselves also. Please try, and then you will be more equipped to do assignments. If there is any doubt that you have, please post it on the forum. So, thank you.